Section 2.6, Two Quantitative Variables, Linear Regression, video number 5. In the last video, we defined what we meant by a residual, and you can see the picture that's still up here. A residual is essentially how far off the line of best fit each point in the scatter plot is. And when I say how far off it is, I mean vertically speaking. So for example, this length represents a residual, as does this length up here, and all the other lengths. Keep in mind that the points below the line have negative residuals, because residual is what we observe minus what the line predicts. Whereas the points above the line of best fit have positive residuals, because what we observed is greater than what the line would have predicted in terms of the response variable, in this case margin of victory. So, what's a line of best fit? Well, let's think about it. If we tried to find a line that most closely fits these points, how would we measure how far off the points are from a line? Well, we could look at all the residuals and add them and try to get the smallest possible sum for residuals. But there's a problem with that. If all we tried to do is find a line that minimized the sum of the residuals, you could always find an infinite number of lines where the sum of the residuals was 0. And it's actually pretty easy to prove. For example, let's take this horizontal line that's above all the points. I know all the residuals would be negative, so the sum of all the residuals would also be negative. Now, if I slide this line until it's below all the points, then all the residuals would be positive, and so their sum would be positive. And as this line moves up and down, that sum fluctuates. So up here, the sum of all the residuals would be negative. Down here, the sum of all the residuals would be positive. In order for the sum of the residuals to transition from negative to positive, somewhere in the middle, the sum of the residuals would have to be 0. That's a continuity argument, but it's a calculus thing. Sum of the residuals is negative, sum of the residuals is positive. Somewhere in the middle, the sum of the residuals would be 0. But what if the line wasn't horizontal? What if I tilted it a little bit? Well, sum of the residuals is negative, sum of the residuals is positive. Somewhere in the middle, the sum of the residuals is 0. And it wouldn't matter how my slope was. I could even slope it downwards. If I raise it high enough above all of the points in the scatter plot, the sum of the residuals would be negative. And if I lowered it far enough, the sum of the residuals would be positive. So somewhere in the middle, the sum of the residuals would be 0. So I can make the line have any slope I want, and there's going to be a point where the sum of the residuals is 0. So if we're going to define a line of best fit, it would be good if that line were unique, not an infinite number of them. So how can we fix this? The way we can fix it is kind of the same way that they addressed standard deviation when that was created in Statistics 1. Without writing it all up here, if you take all the deviations of points in a data set, remember deviations are the points minus the mean. But if you calculate this for every point in a data set, the sum of these will always be 0. So what did they do in the formula for standard deviation to prevent the sum of the deviations from always being 0? They squared them all, made them positive, had no chance of canceling. And that's the same thing, the same approach that we would take here. To find the line of best fit, you have to answer the question, what line minimizes the sum of the squared residuals? By squaring all these residuals, remember it's just the length of the lines, positive if it's up here, negative if it's down here. If we square the residuals, they'll all become positive. And now the question is there a line where we can minimize the sum of the squared residuals? The answer is yes. In fact, What line minimizes the sum of the squared residuals? There is a unique line that achieves this. If I can spell. Showing that line is unique is a calculus problem, so we'll spare the details. That line is called, well, it's called any of these things up here. The least squares line, and now that name makes a little bit more sense. The line of best fit, because it best fits the scatter plot, and it's also called the regression line. How do you come up with the equation for the regression line? Well, there are formulas that will take all the numbers in these ordered pairs and produce the two pieces of information that you need, the intercept and the slope. If you're curious about those formulas, I would allude you to, well, I thought there was a page in the textbook where they say, by the way, here's the formulas. I'm not seeing them. I know they exist. Just realize that you're not going to have to worry about them. There is a way to take Microsoft Excel and come up with the equation of a line of best fit for points in the scatter plot. I'll try to make another video that shows you how to do that. But for now, you can assume that you will be given the equation of the line of best fit. Just remember that what it accomplishes is it is the unique line that will minimize the sum of the squared residuals.